Solve the second derivative minus the first derivative minus 2 times y is equal to cos x. So we've got a second order differential equation here. So this is type A of the second derivative plus b times the first derivative plus c times y is equal to some function of x. The full solution will have the complementary function and plus the particular integral. The complementary function, CF, is y, if we let y equal e to the mx, differentiate that, we get me to the mx. Differentiate that again, get second derivative m squared e to the mx. We substitute that into our differential equation, but to the right hand side being equal to 0, not cos x. So we get m squared e to the mx minus me to the mx minus 2e to the mx is equal to 0. E to the mx comes out, and we're left with m squared minus m minus 2 is equal to 0. This is called the auxiliary equation. As the e to the mx is always greater than 0, then the auxiliary equation mx squared minus m minus 2 is equal to 0. We'll solve that. So we get m minus 2 plus 1, which gives m is equal to 2, or m is equal to minus 1. So we're going to get y is equal to a e to the 2x and b e to the minus x, where a and b are arbitrary constants. The particular integral, pi, we're going to try lambda cos x plus mu sine x, because our differential equation had cos x at the end of it. If we differentiate cos, we get minus sine, so we get minus lambda sine x plus mu cos x. If we differentiate again, we get minus lambda cos x. If we differentiate that, we're going to get minus mu sine x. We now substitute this into the full differential equation. So the second derivative minus the first derivative minus 2y is equal to cos x. So we've got this, minus lambda cos x minus mu sine x, minus brackets this, be very careful, so minus lambda sine x plus mu cos x, minus 2 times y, which is lambda cos x plus mu sine x. Removing the brackets, that's equal to cos x. Removing the brackets, we're going to get here minus minus, which is plus lambda sine x minus mu cos x minus 2 lambda cos x, and minus times a plus makes minus 2 mu sine x. That's still equal to cos x. Collecting up like terms, we've got a minus lambda cos minus mu cos minus 2 lambda cos. So minus 2 lambda minus lambda makes minus 3 lambda minus mu cos x. And then for sine, we've got minus mu plus lambda minus 2 mu. So we're going to get lambda minus 3 mu sine x. That's still equal to cos x. So equating coefficients, the coefficient here is 1. So we're going to have minus 3 lambda minus mu has to be equal to 1. And then we're going to have lambda minus 3 mu. There's no sine x, so we're just going to put that equal to 0. Right, so we need to solve these two simultaneously. Well, from this one here, we can say that lambda is 3 mu. We're going to number them now 1 and 2. Substitute that into 1. We're going to have 3 times 3 mu, 3 times lambda, minus 3 times lambda, which is minus 3 times 3 mu. Minus mu is equal to 1. That's going to be minus 9 mu minus mu is equal to 1. Minus 10 mu is equal to 1. Mu is minus 1/10. I'm going to substitute that back into equation 2. So we're going to have lambda minus 3 times 1 minus 1/10 is equal to 0. So lambda plus 3/10 is equal to 0. Lambda will be equal to minus 3/10. So the particular integral will be y is equal to lambda cos x. So that's going to be Right, so the pi will be lambda cos x, so it's minus 3 over 10 cos x plus mu sine x, so it's minus 1/10 sine x. Y will be the complementary function plus the particular integral. So the complementary function was a e to the 2x plus b e to the minus x. And then we need to take away minus 3 over 10 cos x minus 1 over 10 sine x as the full solution. So it's been a video to show you how to solve a second order differential equation. I hope you've understood. Thank you very much for watching.